Today's teardown is on a Toyota product, and I know I haven't done any yet, so I figured it was time. This is the 1UR engine. It comes in LS460s and GS460s. It's a 4.6 liter dual cam direct injected V8. It's like 380 something horsepower. They're pretty neat engines, and for the most part I believe these are pretty reliable and robust engines, and the reason for that is they are difficult to sell used. There's a lot of them available, and I see them at the auction with 200,000 miles on them all the time, and the cars look great, and obviously they're wrecked, but I think they're pretty good engines. But this is going to be the first time I've ever torn one down. And I can also tell you that I bought this engine for one reason, well, two reasons, but one major reason, and that are the cam sensors on the front. I know they're called something else, but we're going to call them cam sensors for the sake of this argument. These are a crash item. They have connectors that face forward, and they get broken in a wreck, and I get pretty good money out of both sides. So if nothing else in here is good, if it's all trash, I throw it all away or in the scrap bin, I'll still come out all right. And then I'll also have a video to show you guys. So it works out in the end. But anyway, we're going to look around this thing and see if we can see any clues as to why this engine is not in the vehicle it came from. Right off the bat, you can see someone has written compression numbers on it. And you've got 250, 250, 200, and 250. So also this one is missing the plug. Well, I think they're all missing plugs. Yeah, none of them have plugs, but this one's missing the ignition coil. So that tells me maybe there's a problem with this cylinder. I mean, do we trust this? Maybe. There's also a stock number from a salvage yard, so that's interesting. This side also has some compression numbers written on it. It's 250 across the board. So maybe this is the good side. I also noticed the oil filter housing is loose. Either that got swapped out or it was pulled to inspect. Maybe it has an oiling issue, maybe oil and compression issue. We will find out. I also noted that there is a heat tab underneath this exhaust port. And salvage yards put these on to ensure that they can tell whether an engine has been overheated or not. See, if the engine gets over a certain temperature, this will melt and fall off. The adhesive will melt and this will fall off. So this is missing, then they know the engine got too hot. It also has a VIN number, which will be interesting. I'll probably run a Carfax on it to figure out that, and maybe we'll find some auction pictures on the Google. We'll find out. The back of this engine has some damage. It looks like this got set on something with the weight of the engine. The cover is broken off of one of the injector drivers. The actuator connector is broken off for the intake manifold tumble control, or whatever Toyota calls it. The arm is crammed down. Oh, there it is, crammed down in there. So there's a little bit of damage, but overall it's not beat up too bad. We're going to start off pulling the driver's side valve cover, since this is the side that has the suspiciously low compression number written on this. We're going to just go ahead and start zipping some stuff apart. Again, it's the first time I've taken one apart, so if I do something out of order or call something by the wrong name, it's because I haven't done this before. Before we start zipping the valve cover all the way off, we need to remove the high pressure fuel pump. This engine has one on each bank, similar to the other V6s and V8 engines that are direct injected from this era. So these are worth a little bit of money, at least they used to be. So we're gonna go ahead and pull this, and then we can get the valve cover off. This is a cam-driven high pressure fuel pump. I like to check these for wear. There is you can tell a little bit of wear on it, but it's not really too bad. The cam looks pretty good. We're gonna go ahead and get the spacer and gasket out of the way, and then we'll get the valve cover off. I think we're ready to come off. This is extremely clean on the inside. There's not a lot of oil varnish. Everything looks very nice. The cams look nice. I think these are hollow cams, if I'm not mistaken. You can see the provision for the high pressure fuel pump. And that's about the only thing that looks questionable. And again, my experience with these is so limited. I don't know if that's normal or if that tensioner has lost its pressure, but it still has some decent tension to it, so maybe that's normal. Now we're going to peel off the passenger side valve cover. I noted that the variable valve timing solenoid It's broken off. This is kind of typical when you get cores, as well as another cam position sensor that's on the top of the valve cover is broken off, so something must have hit this part of the engine when it was moved around or being stored. I have no idea, again, the history of this. The banjo bolt that holds this line on is the pulsation damper. Pretty good use of that. Yep, everything looks normal. This side looks just like the other. It is extremely clean. There's no oil varnish. I don't see any wear on any of the cam lobes. No signs of any kind of major damage. I'm going to spend a little time and try to get this harness off. I'm also going to pull these injector driver modules. This one's broken. The connector on this one's broken, but it might have made it. I don't think these are worth a whole bunch anyway. But we're going to go ahead and get them out of the way. Well, that broke. I've got the engine harness off of it, some of the coolant pipes out of the way, so we can just go ahead and pull the intake manifold off. Should be it. Coolant hose left. So let's go ahead and pull the port fuel injectors and rails out. I am going to disconnect the high pressure rails and injectors, but I'm going to leave them in the cylinder head. It's been my experience that they can be very difficult to get out of the heads. I'd rather run them through the parts washer, get them hot, get the carbon broken up, and hopefully I'll have the best chance of getting them out unscathed. So let's go ahead and pull these rails and injectors. This is part of the crankcase ventilation here. We're going to get this out of the valley. It'll make it easier to pull the high pressure injection harness. I've got the valley stripped bare. You can see there's some sort of buildup of, I don't know really what this is. We're going to go ahead and start peeling parts off of the front of the engine. We're going to go ahead and pull the coolant crossover and thermostat housing, and then we can get my expensive parts off here. Wow, nothing's really leaked yet. Now we can see the water pump here. Let's go ahead and get these out of the way. Water pump and pretty interesting gasket. That looks, I'm not going to say it. Before I go ahead and take the harmonic balancer off, I want you to note how they balanced it. It looks like they have hammer-on weights, like they're similar to wheel weights. We're going to go ahead and pull the oil filter housing off. See what the oil looks like, if there's any in there. Pretty much empty. This one is actually drained. There's a little bit of shiny stuff in there. Now it's time to pull the timing cover, which is a one-piece cover. It looks like it'll come off pretty easy. It does have access plugs for the timing chain tensioners, I'm assuming. The timing cover has the oil pump built in, and it all looks really clean, except there's a fair bit of metal looking debris here. Got some sparklies. This is where the pickup feed meets the oil pump that's in the timing cover, and there are some chunks of metal in here. We're gonna find something in here. First I thought maybe we just see cylinder out of round or some collapsed rings, but I think there's something that came apart. I'm gonna go ahead and pull the timing chain tensioners and guides off so that we can get the eventually get the cams out and the heads off. These are oil pressure fed. Something I can notice now that the chains are off, this is the side I thought the tensioner has failed, and I'm not going to say that this is the appropriate pressure. I don't know what it's supposed to feel like. However, if you notice this side the tensioner is on the bottom and it has a guide on the top. This side the tensioner is on the top and there's a place for a guide on the bottom, but there's no guide. So where did the guide go? Now we might find that in the oil pan. And these heads have a pretty cool design. I'll show you that as soon as I get this apart and get the cams out of it. So let's go ahead and get these caps loose and get the cams out. Already seeing some debris here. It's not a good sign. You can see this is the cam lobe that drives the high pressure fuel pump. It does have some scoring where it sits in the journal. It's not too bad. This journal, I can't really feel it. I'm also wearing gloves, so that's probably part of it. But visually it looks like there's been some debris that has run through the oiling system. One design feature of this engine that I noticed as I started to pull it apart is these have a cam plate. There's a few benefits to that the way I see it. To get to the head bolts you have to pull the cam plate off, which we're going to pull that off next, but the cam sits between those cam caps and this plate. And this plate is not one piece with the head. On most cylinder heads, most overhead cam cylinder heads, you'll find that the cam rides in the head. So in this situation, if the head was good, but the cam journals were worn out, you could replace this plate and the cams and with new caps and put all new parts on it and not have to buy a complete cylinder head. And conversely, if the cylinder head was bad and the cams and this plate and the caps were in good shape, then you could put all of those on a good cylinder head. I really like this design. I wish there was better access to the head bolts and you could leave this on. However, it's just a ring of bolts. It doesn't even look like a ring. It looks like just a handful of bolts to get this off, and then we'll have access to the head bolts. Time to get the head bolts out. They are my favorite fastener ever. They're a triple square. We're going to need the big impact for this one. Ooh boy. boy, these are tight. These are just so hard to get off the fastener. All right, let's get this head off. Something that stuck out as soon as I got the head off, if you look at these pistons, they all have a similar carbon pattern where carbon is and where carbon isn't. And if you look at this cylinder, and this cylinder, the pistons have carbon in the exact same places. However, this one has no carbon here at the crown. And the only way that happens, I think you guys have seen videos past, is if you have a little loose rod bearing. So let's push on this. I think we have our problem. The rest of these, oh, that one moved too. So we have multiple rod bearings. Here's the cylinder head from that bank. And the only damage I see is a little bit of damage right here. This is that cylinder head the most play. And you can tell that the carbon has been forced off of this part of the combustion chamber. There's a little bit of damage from that. Not too bad. It's definitely a serviceable head. Moving on to the passenger side head, we're going to go ahead and pull the cam caps off so we can get the cams out, get the cam plate off, and ultimately pull the cylinder head. Looks just like the other side. There's some scoring. Not terrible, but not great. Cams look all right, but the journals in that cam plate show no damage whatsoever. Those look really good. Let's get this cam plate off so we can have access to the head bolts. Yep, we're loose. There doesn't seem to be anything loose on this side. The bores all look good, the pistons all look all right. So it is time to flip this over and pull the bottom end apart. Now that I've got the engine turned over, I've noticed that only 2 bolts are in the lower oil pan, so someone's definitely been in here. But I would wager it was more for inspection and not trying to fix a problem the wrong way. So I think we're gonna get these 2 bolts out and this pan will just lift off. Yep. Whoa. The amount of metal in this pan is just wild. A ton of it. You can definitely tell it's all bearing material. There's big pieces, little pieces, sparkly pieces, dull pieces. A whole species of pieces. Wow. Now that we've got the upper pan off and out of the way, that came out with the windage tray, we can see the rotating assembly. We can kind of check to see any damage here. Oh, I don't think there's any bearing left in there. Let's turn this over. Now there were two, but I'm not feeling any play. I don't remember what cylinder that was. Oh, there it is. That one probably still has a bearing, just less of one. So let's go ahead and pull the rods and pistons out and we'll inspect the crank. That bearing was spun and I can't get it out. Here's the front cylinder's rod bearings, which are currently stuck to the crank. I bet if I pull these off I can get them off, but they are spun. I don't even see where the gap is. So those might be welded to the crank. Let's keep going. Oh, look, that spun bearing's coming out. Kind of coming out. Wow. Wow, it's chewed up. No bearing. No bearing at all. And as you go towards the back of the engine, there's the bearings next to the one that, well, it did disappear. We know where it went. It was all in the pan. And the rear cylinders look pretty decent. I wonder why this particular cylinder was the worst one, and then one of the front cylinders was the second worst one. I really don't know the oiling system that well on these engines, but I'm sure there's a reasonable explanation. Here you can see the difference between what it's supposed to look like and when the bearing decides it wants to be in the pan. One thing I did note is that it is still a little too difficult for my liking to be able to turn the crank over. There should be no resistance at all. It should just be main bearings, and it's a little tight. So I think we're going to find some more damage. Time to pull the crank out. Each of these main caps, they're 6-bolt mains. So we're going to pull the side bolts out first, and then we'll pull the top ones. Wow. Spun the front main. I did not expect that. Not at all. That one has damage, but it is not spun. Not like the front one. This is the thrust bearing here. Oh, there it goes. I'm just dropping everything today. That one's pretty worn too, but again, it's still in the right place. That one's worn. Man, the grooves are deep on these things. But again, that one was not spun. Yeah, they're all grooved pretty bad, but that was only the front one was spun. It's kind of a shame too. All right, let's get this crank out. The main bearings are pretty trashed. Bottom of the bores look nice. The block looks really good except for where it spun the main. And I don't know that that's going to be the kiss of death for this block. I don't know that it would be worth the machine work to get that straightened out. These engines are pretty plentiful to use, so I would imagine it's not. As you can see, the crank, you can tell where the bearings were damaged and where the bearings weren't. The main journals are pretty chewed up, but not terrible. Let's try to get this spun main off of here. Let go. Yeah, it's pretty gnarly. That's grooved up pretty good. I think that's going to be in the scrap bin. One thing I'd like to point out is you see these numbers right here. They're stamped into the block. These are bearing sizes, I'm pretty sure. Toyota and several other manufacturers use bearing sizes, but I haven't seen them marked like this in a while. You know, when they go to build these engines, there are certain tolerances and certain size bearings, and those are the corresponding bearings. So there's some 8s, some 6s, and a 5. All in all, that was a pretty easy teardown. And in fact, I learned a lot taking that engine apart. Again, that was the very first one I've ever done, and I really like the construction of that engine. As far as how it blew up, I'm not quite sure. Actually, the compression numbers really threw me. I don't know why you do a compression test on an engine that had to have horrific rod knock. I mean, it had to sound terrible, unless maybe they did a compression test on it and had low compression in one cylinder that was causing a misfire, or maybe they drained the oil and ran it without oil. These are questions we will never know. Anyway, I hope you guys had fun watching this video. I've got something very special for the next teardown, something that has been the #1 requested engine to break down, and I'm pretty excited to get into it, so catch you on the next one.